Hey guys, so we're looking at longest substring without repeating characters on LeetCode. So we're given some string S and we have to find the length of the longest substring without repeating characters. So given a string like A, B, C, A, B, C, B, B, we have to return 3 because the longest substrings without repeating characters are A, B, C and B, C, A. But anything other than that, for example, this substring here has a lot of B's in it, this substring here has duplicate A's in it, and something like a series of B's, we just have to return 1 because B is the longest substring we can have. And in this example, it looks like the longest substring is length 3 of WKE. Okay, so let's have a look at how we can solve this problem. So I've got an example string here, and below I'm just showing all possible substrings of this string. So for the brute force solution, we would have to find all possible substrings, and you can see we can do this by taking the first character and then appending the next character in the string, and then just keep doing this iteratively until we reach the end of the string. And once we're done with the first character, we can do the same thing but with the second character, and then this keeps going on all the way for all characters in the string. So to generate all possible substrings, it's going to be an order of n squared operation, and then we're going to have to go through each substring and we're going to have to find the longest substring that doesn't have any duplicates. So I think that's going to be this one here, 3. And in order to find the longest substring without any duplicates, we would have to go through each of these substrings and just check each character and check if there's no duplicates. So that's going to be an order of n operation for n squared substrings. So that's going to be an order of n cubed operation for the brute force solution. So there is a faster way to do this problem, and we're going to have a look at that now. Now I'm going to be going through the optimized solution. At the top I have the string. We have 2 pointers, slow and fast. S is for slow and F is for fast. And we're going to be using those 2 pointers to help us determine the start and end of our substring. We're going to be using a hash map to help us detect duplicates. So we're going to be checking each character that this pointer F is pointing to see if it's already in our hash map. And we're also going to be keeping a track of the length and the max length of the substring without duplicates. Here below I've posted a simple just procedure we're going to be following if the character is unique and if it's going to be duplicated, but we're going to see this in action in the example above. So here we have our first character T, F is pointing at T, and T is not in our hash map, so we have to add it and its position. So we then calculate the length, which is just going to be 1 because it's just one character, and then we just increment our fast pointer to M. Again, M is a unique character, so we add it to our hash, M and its position 1. The length would be 2 because we have 2 characters in our substring now. And then we need to increment F again to X. So now we have TMX as our substring. X is another unique character, so we need to add it to our hash map. And our length is 3 and our max length becomes 3. And then we need to increment F again. Interestingly, we reach our first duplicate. So we're going to be following this procedure now. So on our first duplicate, we now need to move S to wherever the old duplicate was plus 1. So the reason for this is in order to remove the duplication, here M is being duplicated, so we need to move S to this X in order to get rid of that duplication, and in doing so we're going to be defining a new substring from X to M. And the question is, how do we know where to move S? Well, we can just look in the hash map because the element being duplicated is M, and we know that the last position M was in is going to be position 1, so we just have to move S to the old duplicate plus 1, so it's just going to be 1 plus 1, so we have to move S to position 2, which is going to be this X here. And as you see, we have a new substring now, x and m, where there are no duplicates. And then we can update our hash value because we have a new substring. So this is going to be 2. So we now calculate L for this new substring, x and m, and that's going to be 2. Our max L is still going to be 3 from previous. And then following our procedure, we can now increment f. We now run into another m, so we have yet another duplicate because we already had an m in our existing substring. So we follow the same procedure. Where do we need to move s in order to get rid of this duplication? Well, we can look at the last position that m was in, which is position 2, and we can move it to 1 past that position in order to get rid of the duplication. So that means we're going to have to move s to 2 plus 1, which is 3. So we're going to have to move s right here. And then we can then we can update this value. So we've got a new string now of just m. And then we can calculate the length of just this string, which is just going to be 1. Of course, the max length is still going to be 3 from previous. And then we can increment f. So then we increment f to z. And we've not encountered z before, so we can add it to our hash map right at the end. And then we can calculate, so we're following the unique procedure. We've added z to our hash. We now need to calculate L, which is going to be the length of this substring, m and z. So that's going to be 2, and our max length is still going to be 3. And well, now we've reached the end of our string, so there's nothing else to check. So we can look in our max length, and we see that the max length was 3. And it was 3 since this step here. And this is going to be our first substring, tmx. And this agrees with our seemingly brute force solution that we walked through right at the beginning, where we saw that tmx was the longest substring without duplicates. So now I'm just going to show you this in code. So here I'm just showing the code on how to implement this procedure. We can go through it. So here I have created the variables max length, our fast and slow pointers. I've also created a hash map, and I've got this in a while loop. So we're saying while fast and slow is less than the length of the string. We now have our unique procedure. So if our map does not contain the character, then we're going to be adding it to our hash. We're going to be calculating the max length, and we're going to be incrementing our fast pointer. So that's already what we've covered here. Else it's going to be a duplicate, and I've just added an extra check here that when we move s to the old duplicate position +1, we just want to make sure that the duplicate is actually a legitimate duplicate and is greater than whatever our slow pointer is. So as an example, if you have something like aber, if you follow this procedure, you're going to have something that looks like slow here, you're going to have fast here, and then you're going to say, in your hash map, you'll have, in your hash, you're going to have A at 0, you're going to have B at 1, and your fast pointer is going to say, oh, we've already run into a B here, so that means we need to move S, you need to move S to the position of this B here, S. And then you're going to increment f again. Sorry, so let me do that properly. So you're going to move s here, and then you're going to increment f here. And then you're going to be saying, well, is this a already in a hash? And you're going to say, yes, it is. But a is at 0. And if you follow this procedure, you're going to be saying, move s to wherever it was previously, which is 0 plus 1. So you're going to be moving s backwards here, which doesn't make sense. So I've just put in a check here that says basically ignore duplicates if it's going to be previous, if it's going to be behind our slow pointer. So only update it if it's going to be greater than our slow pointer. Otherwise, we just follow our usual procedure for duplicate. We update the position of the duplicate in our hash map, and then we calculate the length, and then we increment the fast pointer. So you can see that I've run this already. And sorry, just before I forget to mention, this is going to be an O of n solution, because you have a fast and slow pointer, and you're just going to be incrementing or iterating through the string once, and that's going to be an improvement over the brute force solution we discussed previously, which is going to be order of n cubed. So I'm just going to run this code now and see that it works. So yeah, you can see that it works. So if you found that useful, please like and subscribe, and hope to see you soon.